Hello everyone, this is Stylianos Physics, and today we will see how to add any two methods. As you know, we can graphically add two methods by using the head to tail method. This means that we transfer the two vectors in a way that the head of the first will be at the tail of the other, and the resultant vector is a vector that starts from the beginning of the first and finishes at the end of the last. Now let's consider that our vector A is equal to 10 and our vector B is also equal to 10, and you can see that the angle between them is approximately 150 degrees. Now we can calculate the resultant vector R and its direction by applying the cosine-sine rule. In this case, the resultant vector R will be equal with square root of a squared plus b squared minus 2a times b times cosine of the angle between the two vectors, where we can substitute of the values of a and b, and of course the angle of the angle between our vector A and our vector B is 150 degrees. In this case, we need to be a little bit careful because of the angle between them is 150 degrees and the cosine of 150 degrees is negative. So the two negatives of the cosine and the before the 2 will give us a positive value in total. And of course, if we do the calculations, this will be equal with radical of 200 plus 200 times 0.86. This is around 173. So this is equal to radical of 173, and the resultant vector will have a magnitude of around 19.3. Now it's time to try to find something about the direction of the resultant vector. In this case, we will say that the angle between the two vectors is theta, and the angle that is opposite to the side B to vector B is called B, and the angle that is opposite to vector A, it is A. Now we apply the sine rule, which says that sine of A over A is equal sine B over B is equal sine of theta over the resultant vector R. We're going to use the last two fractions because we happen to know how much is vector B, or because I find it easier. Now sine of B over vector B, which is 10, is equal sine of theta, theta though is 150 degrees, over the resultant vector that we have just calculated. We can cross multiply sine of B times 193, sorry, 19.3. This will be equal 10 times sine of 150. Sine of 150 happens to be 0.5. Now sine of B times 19.3 is equal 5, and if we do the math, B will be equal to the inverse sine of 5 over 19.3. This is 15 degrees above the vector A. The second way of calculating the resultant of two vectors is by resolving our vectors into their components. In this case, we'll transfer the second vector to have the same beginning at the beginning of the two axes. So we have one vector A equal with 10 that it is upward by 30 degrees, and one vector B that we can measure it with a protractor. It looks around 60 degrees above the positive x-axis. As the title of the method suggests, this in the first step is to draw the two components of our vectors to the x-axis and of course to the y-axis. So we have a vector AX and a vector AY upward, and of course a vector BX and a vector BY. We need to apply the rule to calculate how much are the components. AX will be equal A times cosine of 30. Now A is 10 cosine of 30 is radical 3 over 2. The result is 5 times radical 3. We need to apply the rule for ay. Ay equal a times sine of 30. This will be equal with 5. And we need to apply the same rule in order to find the components of b, bx and by. Bx will be equal with 5 and by will be equal with 5 times radical 3. The next step suggests that we need to find how much is the total r. Now, we have calculated the components, so basically our two initial vectors are useless. We don't need them anymore. We can even delete them if we have the opportunity to do so. So we have a total on the x that consists of ax plus bx. This will be called the rx as resultant x. This is radical 3 times 5 plus 5. This is around 13.6. And the total on the y will be ry equal ay plus by, which will have the same value, 13.6. Now, because these two vectors are perpendicular, we can calculate the resultant vector from the Pythagoras theorem. Radical rx squared plus radical ry squared. And if we do the calculation, we will find something around 19. The result will be 19.2. The next step is to say something about the direction of the resultant vector. In this case, the direction of the resultant vector will be equal with an angle which is equal tangent to the power of minus 1 ry over rx. This is equal inverse tangent of 13.6 over 13.6. This will be equal with 45 degrees. Thanks for watching.